In this video, I'm going to introduce exclusive OR and then do a couple questions with it. So on an exam, you may see a logical operator that you've never seen before, so that's why this is a exercise video and not a lecture video. So we want to write the truth table for exclusive OR, which is P circle cross Q. I'm just going to use the exclusive OR symbol, that's what we'll call it. And then we'll state whether P exclusive OR P exclusive OR P is a tautology, contradiction, or neither. This is also called XOR or XOR. I guess I'll call it XOR. Okay, so XOR is true if and only if P and Q have different values. So here we have P XOR Q. So let's put our truth values in here. So it can be 1, 1, 0, 0, 1, 0, 1, 0. I'm actually going to make this a little bit shorter. Okay, so it's true when P and Q are different. So in the first row, they're the same, so that's going to be false. Second and third row, they're different, so we'll get true. And then in the last row, they're both false, so our P XOR Q is false. So now we want the P XOR P XOR P. Okay, so let's do a truth table for this. We can make it a little bit smaller, so we can have P XOR P. Then for our third column, we can have P XOR P XOR P. Okay, so we only have two conditions in this one. That's why I didn't continue it in the first. So P can be a 1 or a 0. Well, P is always going to be the same value as itself, so P XOR P will be 0. Same in the second row. And then in the third row, we're saying, okay, is our first column different from our second column? And in the first case, yes, because P is a 1 and P XOR P is a 0. But in the second row, it's not. So we can see here that P XOR P XOR P is logically equivalent to just saying P. So that is the first question. It is neither a tautology nor a contradiction. Okay, second question. Let's give the truth table for P XOR Q or P XOR not Q. So again, another truth table question. So let's set this up. We have P, Q. Oh, that is not a straight line. We're going to need not Q. And we're also going to need P XOR Q, P XOR not Q, and then we're just going to call this X or Y, and we'll label this first one as X, the second one as Y, just so we don't have to write as much. Okay, so let's set this up. 1, 1, 0, 0, 1, 0, 1, 0. Not Q is going to be 0, 1, 0, 1. So P XOR Q is going to be 1 when the values are different. So we're going to get 0, 1, 1, 0. For P XOR not Q, well, in the first row, P and Q are different, or P and not Q are different. So we have a 1. The second row, they're the same. Third row, they're the same. Fourth row, they are different. So now we want X or Y. So this is P XOR Q or P XOR not Q. And we can see that they're different for every single row. So this is 1, 1, 1, 1, 1. So we can say here that this is a tautology. So this is always true. P XOR Q or P XOR not Q is always true. So that is it. In fact, actually I should mention before I say that's it, this row right here, P XOR not Q, this is very similar to a statement which is P biconditional Q. So what this really says is X or Y is saying, are the two values different or are the two values the same? Well, it's always going to be one of those cases. So that's why we see that this disjunction is a tautology. Okay, so that's it for exclusive OR. If you have any questions, please leave them in the comments below, and I'll answer them the best that I can.